Hello everyone. So today we will see NumPy indexing and selection. How we can do indexing, how we can access elements at certain indexes, how we can select elements in NumPy 1D and 2D arrays. So the last time we saw NumPy arrays and now let's create our another notebook on our Google Drive. Right click anywhere and create a new Google Collaboratory file. Wait for Google Collab to finish its work and give you this beautiful file, and now click connect. While it's connecting, let's name this indexing and selection. Alright, let's enter. So first off, let's create a text cell and let's move it above the code cell. Double click and enter numpy indexing and selection. Select all and then press this T. This will make this a heading. So if you press escape, it will take you out of this. If you want to go back and do your editing, you can double click this and it will take you back into the editing mode. Once you're done there, you can click on the text, the code cell. This is the code cell and this is the text cell. Now in the code cell, we can import our numpy like this. Import numpy as np and press alt enter to run the cell and create a new cell in the same with the same key press, and now we have imported our numpy and we are ready to go. So let's create an array. If you remember from our last video, we can create a 1D array by just simply typing np.arrange, and this will give you option to create a 1D array. As you can see, it also tells you the documentation. You can, and this takes three arguments. First is the start and the stop and the data type. For now we can just give it this one input, that is 5, and all this is saying is give me uh, an array which starts from 0 and ends at 4. This 5 means give me 5 elements, but up to 5, not including 5. So it gives us 0 to 4. These are the 5 elements it gives us. Okay, so if you have worked with any programming language, you may be familiar with arrays, and we can just access arrays in NumPy as we did in any other language. For example, Python, you can just access this using these square brackets. For example, we want the first element, we'll say, and it will print 0. At the index 5, we have 4. Oh, sorry, we do not have an index 5 because we only have index up to index 4. At index number 5 we have the number 4. So this is how we can access these 1D array. Okay, now let's create another cell, and the other beautiful thing about NumPy is that we can get a range of numbers. For example, I want to get numbers between the range of 1 to 8. So we can do this by simply typing this, the starting index colon, and the index that we want to. The 1 is included, but the 8 is not included. It will go from 1 till 7. In data science, we usually see scenarios where we want numbers in an array within a range. This is how we can do that. If we want a number, for example, we want to say here's our number, our starting index, and go all the way to the end of the array. Start from the index 1 and go all the way. So it will start from index 1 and give me everything included in the array. If we want something like this, 2D and 8, this will give us everything up to the number 7. As you can see, it starts from 0, everything is included in the array, and it stops at the index 8. Okay, now the special thing about NumPy arrays is that there's a concept called broadcasting. Let me show you what I mean by broadcasting. Okay, for example, we have this array 2D, and we want a copy of this array. Okay, let's say copy equal to 2D I want everything up to index 5. Okay, and let's see what do we get in this copy. Okay, we get these numbers, these 5 numbers, and if we say copy equals or copy start to the fourth number, and I want this to be equal to 100. If we do this, now you can see that the first 4 numbers will be 100. This is very powerful, and this is something which you can do only in Numpy, and this is called broadcasting. Okay, this is powerful. Now if we see the original array, as you can see, it has also changed. So far we have seen how we can select from an array based on this slice notation. This is called slice notation. We can also get everything of an array just like this. This will only giving this single column will output everything in the array. Okay, this is called the slice notation. So now let's see how we can make. Alright, so now let's see how we can create copies of an existing array. So there is something we need to be careful about this when making a copy of an array, because let's say we have this array which goes from 0 to 10 and we want a copy of this. Okay, ARR, let's say I want the first 8 elements. Now it has given me these first 8 elements in the array. Now if I change something in this array, for example, let's say I want the first 4 elements to be 100. As you can see, this is something which is called broadcasting. It is, I think we already discussed, it has broadcasted this 100 to the first 4 elements of this array. And the interesting thing we have to be careful about is if we check the original array, you can see it has already also changed, because this copy is, you can say, it's just a view of the original array. If you want to create a copy, you have to mention explicitly that you want a copy from the original array, just like this. This is a function in Numpy where you tell it that please give me a copy of this original array. Now if we do copy ARR4 equals 200, but first let's refresh this ARR. Okay, print ARR, and also print copy ARR. So as you can see, after when we created the copy like this, we changed the original array without actually changing it. But if we copied the array like this with explicitly telling it to make a copy of the array and then changing it in some way, we do not change the original array, we only change the copy. So this is something you have to be careful about in NumPy. The next thing I want to discuss is 2D arrays. Let's go ahead and create a 2D array. np.array 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, this is a 3 by 3 2D array in NumPy. It's simply created from Python list. Here's how we can make selections on a 2D array. ARR 2D 1 and 1. Here we have to be careful. The indexing starts from 0. This is the 0th row and this is the 0th column. Okay. If we say 1 1, then we mean the first row 0 1 2. Okay. For one row and the one column. So it will return this 9. Yeah, there are 2 ways in which we can make this selection. There's another representation. It goes like this: 1 1. It is similar to the one above, but This one is more simple and it is more recommended. So whenever you want to make a selection in 2D arrays, go with this notation. Okay, and what else? Now if we select only, if we make a selection like this, it will only give me the first row, index 1 row, only the first row. If we want to get the first 0 and 1 index rows, we can do something like this: 2d 1 2. Okay, it will give us the 0th row and the first row and not the 2. Give me everything but not the second index. So this is how we can make selections. Yeah, we can also make selections in a range. For example, if we want, we can do like start from the first index, go all the way. For the rows, begin with 0th index and do not include the last or the second indexed column. So this is how we can. If we want only this part, 6 7 9 10, here's how we can do that. ARR2D, give me start from first and start from the 0th and go up to 2, but don't include 2, and then start from first and go all the way to 0. This will give me 6 7 9 10. So like I said, we need practice to get good at this. Don't worry if it looks confusing right now. We will explore this much, but we do not use this type of selection very much in our courses. In the later courses, when we use pandas, you'll see we only have to select entire rows or entire columns, or mostly we deal with those. We do not go about selecting chunks like this. So yeah, it's just for your understanding. If you do not understand it, no worries. There's another a very important concept in NumPy. It's called conditional selection, and it is a very, which you can say, a beautiful concept. Let's create another array, np dot arrange 0 and let's see 20. Okay, we want this many, 0 to 20. I defined a condition. Let's say I want numbers which are greater than 5. If we see this array, it will give us this conditional array. Okay, all these numbers, the ones starting from 0 to 4, these will return false because they do not satisfy this condition. What this condition says is if the number is greater than 5, return true. Okay, now if we provide this, if we try to select the array, if we try to print the array, or yeah, we can simply go like this: condition. Okay, it will give us only those elements for which this condition is satisfied, or for which the values at these indexes are true. We can go ahead and use the shortcut like arr is less than 5. It's same as saying, doing it like this. So we can do this and it will give us the same condition. This is used a lot in data science projects, and later in our pandas course we will see that it is a very handy technique and it is also a very powerful one. So these were few tips for selection and NumPy arrays. So for the next part of NumPy, subscribe and like this video, subscribe to the channel, and I'll be coming with a new NumPy array. The next one will be the final NumPy video, and after that we will be taking this into the realm of pandas. Thank you for watching and take care.